and again. It seems we meet in the spaces and on the screen. We always say video notes won't be long, but they always seem so long. Always seem so long. Always seem so long. Hey, thanks for tuning in to this week's edition of video notes for Mr. Flugum's chemistry class. This is about scientific notation and conversions. And so if you're worried about this being a big time review of conversions we've done before, it's a little bit true, but not really, because we're going to be dealing with prefixes and metric system measurements that are extremely small, things like nanometers or picograms. So this should be something fairly new to you. And these measurements are so small that when they're converted, they require us to use scientific notation, right? Because there's so many zeros involved. So just so you know, these video notes, you guys, are going to go on page 38 in your science notebooks. And let's go ahead and get started. All right, so here's some prefixes that you need to know. You're already familiar with milli, right? And these are all measurements that make the base units smaller, right? So that's why we have negative exponents, because we're moving the decimal to the left. All right. If you look right here, these are all the abbreviations for those 4 prefixes. All right. And the one there that looks kind of funky, I had to hand write that. That's a mu for micro. So it's a Greek letter, actually. It's kind of like a U with an extra tail on the front. So that means this, to kind of put things in perspective, right? 1 millimeter is 10 to the negative 3rd meters, right? As you work your way down, 1 picometer, right, is 1 times 10 to the negative 12th meters. All right, folks, so let's try this. Let's try some conversions with this, all right? So we're going to start with this. We have 823 nanometers equals how many meters? Now, remember, nanometers is 10 to the negative 9th meters, right? Okay, so let's start off with that idea. We've got 823 times 10 to the negative 9th meters. Okay, now this isn't in scientific notation though, right? Okay, so I need to take my decimal, which is right here, right? I need to move it 1, 2 spaces to the left. Now because I'm moving it to the left, that's in a positive direction, right? So I've actually got to add 2 to my exponent there. So negative 9 plus 2, my answer is 8.23 times 10 to the negative 7th meters. Okay, so now let's go the other way around, right? 1.56 times 10 to the negative 10th meters. How many picometers is that? Well, we know this, right? A picometer is 1 times 10 to the negative 12th meters, right? Okay. Well, what's the difference? The difference between the conversion that we have and the conversion that we want, right, is 2, right? Negative 10 to negative 12 and the exponent. So that's a factor of 2, right? So I've got this, 1.56 times 10 to the 2nd power picometers. Okay, so let's apply this to a little bit more of a chemistry problem, right? So we've got a solution, and we figured this out, that there's 39 nanograms of barium in 100 milliliters of solution. Well, let's see if we can figure out, okay, how many grams is that? Well, remember nanograms is 10 to the negative 9th, right? Okay, so let's start writing some things down here, right? We've got 39, okay, times 10 to the negative 9th grams then, right? Now if we want to put that in scientific notation, we need to take this decimal and move it 1 place over to the left, right? And when we do that, we add 1 to our exponent. Since our exponent is negative 9, that becomes 3.9 times 10 to the negative 8th grams. Okay. All right. Now, let's say we want to convert that to kilograms. That's not such an easy thing. Okay. Now, think about this, right? I'm going to use a conversion factor here on this one. I've got this, right? 3.9 times 10 to the negative 8th grams, right? Times. I want to convert this into kilograms, right? Okay. So that's 1 kilogram. All right. And that is 1 times 10 to the third grams, because that's 1,000, right? So 1,000 in scientific notation is 1 times 10 to the third. If I do that, okay, basically what I'm doing is I'm going to subtract my exponents, right? So I got negative 8, take away negative 3. I end up with this, right? 3.9 times 10 to the negative 11th kilograms. So here we have a very similar problem. We have 4 picograms of gold in 1 milliliter of seawater. How many grams is that? All right, well, 4.0 picograms. All I need to do is tag on the picogram factor, which is 10 to the negative 12th, right? So I got 4.0 times 10 to the negative 12th grams. Okay, well, that was pretty simple, right? How many grams of gold in 1 liter? Okay, well, I know this, right? I've got 4.0 times 10 to the negative 12th, right, grams in 1 milliliter, right? Okay, well, now I'm going to change that to liters. So what I want to do is this. I'm going to multiply it by a conversion factor. Okay, in this case, I want to get rid of milliliters. So I know this. There's 1 times 10 to the third, right? That's 1,000 milliliters in 1 liter. If I look at my units, the milliliters cancel each other out, right? I end up with grams per liter, which is what I want. As I do this, I just go 4 times 1, that's 4.0, right, times, and then I'm going to add my exponents because I'm multiplying them, right? So negative 12 plus 3 gives me 10 to the negative 9th grams per liter. Thanks for tuning in, folks. I hope this was helpful to you, and I will see you on Thursday. Hope you have a great day.